Hello friends, welcome to the world of chemistry. This is Dr. Vikram Panchal. I am dealing with chemistry spectroscopy. This is chapter of UV visible spectra and lecture number 45. In this lecture, I will explain you numericals based on benzoyl system. We know that we have this compound which is known as benzene. In benzene, all carbons are equivalent. Okay, so we can put substitution at any carbon. That will be the same. There is no isomerism in that case. But once you put any functional group at any one carbon, like this C double bond O, then this is called benzoyl system. This is known as benzoyl system. So benzoyl system is basically aromatic ketone or aromatic carbonyl rather. So it is aromatic carbonyl. That means benzene ring with C double bond O is known as benzoyl system, and here Z is equivalent. Okay, it is very important. Now once you put CO group at any one of this position of carbon of benzene, then this carbon will be number 1. Then we have the 2 carbons having place number 2. Then there are 2 more carbons having number 3 and only 1 carbon with number 4. When substitutions present at second carbon anywhere, it is called ortho substitution. Here also ortho. With reference to main functional group carbonyl. When any other functional group is present at third position, we call it meta substitution. Okay, so here also we have meta substitution on third carbon, and when any substitution present at fourth carbon, it is called para substitution. Okay, as C double bond O is a carbonyl group which is main group, then if Z is equal to carbon, it is called ketone, aromatic ketone, and for that base value will be 246 nanometer. If Z is equal to hydrogen, that means aldehyde, aromatic aldehyde, then we will put 250 nanometer as a base value. And if Z is equal to OH, that means acid, COOH, or OR, that means ester, then we will take 230 nanometer as base values. Okay, these numericals are very simple, and now we have to find out what will be substitution at ortho position, meta position, and para position. If ring residue is present at ortho position, we will add 3 nanometer, for meta 3 nanometer, and for para 7 nanometer. If chlorine is present at ortho position 0, at meta 0, but at para then 10 nanometer. If bromine is present at ortho 2 nanometer, at meta 2 nanometer, but for para 15 nanometer. If OH group is present or OR groups are present at ortho position, then 7 nanometer, for meta also 7 nanometer, but for para 25 nanometer. Okay, so when OH group or OR group is present at meta, add 7 nanometer. For NH2 group at ortho 15 nanometer, at meta 15 nanometer, and at para 58 nanometer. If substitution of tertiary amine is present, NR2 group, then for ortho we will take 20, for meta 20, but for para 45 nanometer. And if sulfur is present, then for ortho 15, meta 15, and para 80 nanometer. So these all values will be given to you when you are going to calculate any numerical based on benzoyl system. Okay, now we'll start with numerical. Number 1 is this one. Now this is aromatic group, a benzene group. We'll have to see what is present at this different carbon of this benzene. First is CHO, and CHO is aldehyde. So our system will be this one. Okay, with this one, and you know this all the whole one is a system now. Okay, so this is our system, and our system will be benzoyl system, in which Z will be H because it is aldehyde, and when Z is H, the base value will be 250 nanometer for this one. Okay, now with reference to this carbon, this is ortho, this is ortho, then we have meta, this is also meta, and this will be para. Okay, so substitution at ortho position. At ortho there is nothing, so for ortho nothing. At meta we have OCH3 for 2 times OCH3. Okay, and if OCH3 present at meta, that means OR group, then we will add 7. For 2 groups we will add 14 nanometers. And for para, OH group is present. When OH group is present at para, we will add 25 nanometer. And then make a total of this, and you can find out lambda maxima. So calculation of lambda maxima for benzoyl system is very, very easy with reference to diene and enol system. Next is PABA. Sometimes they give you this name like PABA. What is PABA? Para amino benzoic acid. So first of all, you have to draw para amino benzoic acid and find out. This is COOH, and at para position NH2 group. So this is your compound. Okay, what will be the system? C double bond O is here. So this is your system where Z is equal to OH. This is Z. So it is basically benzoyl system. This one is benzoyl system, and in benzoyl system Z is equal to OH group, acidic group, and therefore base value will be 230 nanometer for this one. Okay, with reference to this first carbon over here, these two are ortho, then we have meta, and this is para. Substitution present only at para position. So substitution for para position, we have NH2 group, and when NH2 group is present at para, we will add 58 nanometer for this one. Okay, so total of this will be your lambda maxima, and that you have to find out. Okay, next example will be this one. Again, in this case, you can see our system is COOH group, so it is basically acid. So main system is benzoyl system, and in benzoyl system, because it is aromatic acid, Z will be OH group, so it is acid, and for that we will add 230 nanometer as base value. Okay, next is substitution. This will be ortho carbons, then we have meta carbons, and the final will be para carbon. So substitution at ortho carbon, there is one chlorine over here, and for that we will add 0 nanometer. At para position, there will be NR2 group, and when NR2 group is present at para position, we will add 45 nanometer. This value is given, and so that we can find out lambda maxima for this compound. Okay, next example is this one, and here we will see that our system would be COCH3. Okay, our system is COCH3, where Z would be CH3. So it is basically benzoyl system, where Z is equal to carbon, that means ketone, aromatic ketone is present, and for aromatic ketone base value is 246 nanometer. Next is substitution. So first of all, find out Which one is ortho? These two are orthocarbon, then metacarbon, and then paracarbon. So at ortho position, we have OCH3 group. When ortho is having OCH3, we add 7 nanometer. One more substitution at ortho, that is NR2 NCH3 twice. For that we will add 20 nanometer. It is given. At meta there is nothing, but at para position we have OH group, and if there is OH group at para, we will have to add 7 nanometer. So make a total of this, and that will be lambda maxima for this one. Okay, so this way we can calculate lambda maxima. Next condition, next numerical is this one. Okay, here this is very important. Why? Because from the first glance you will not be able to find out which is the system, but there is a system because this carbon is attached to benzene, and then there is C double bond O, so this will be your system. And here Z is equal to this carbon, okay. So here it is again benzoyl system, where Z will be carbon, so ketone, aromatic ketone, and for that we will add 246 nanometer. Okay, next is to label each carbon of the system, and that is why if it is the first carbon, then this will be ortho, this is also ortho, then meta, and para. Okay, substitution at ortho position. Well, this is ring residue at ortho position. Here there is also one ring residue at ortho, so there are two ring residues at ortho position. So when for one ring residue at ortho we add 3, so 6 nanometer for this one. Next is meta. At meta you will find only bromine. Bromine is present at meta position, and for that we will add 2 nanometer. Next is para. At para there is only one substitution, NH2 group. When NH2 is present at para, we will add 58 nanometer. Then make a total of this, and you can find out lambda maxima. Next numerical is this one, where again the system is a little bit difficult, but it's very easy. You can go ahead with this one, C double bond C, and then this is Z. Z is carbon, therefore it is again ketone system. So our main system is benzoyl system, and in benzoyl system Z will be carbon. Z is equal to carbon, so it is ketone, and for that we will add 246 nanometer as base value. Okay, next is substitution. As this is first carbon, so it will be ortho, then meta, and then para. At ortho position, we have OCH3 group, or OME means OCH3 group, OR, so for that we will add 7 nanometer. Well, one more is present over here at ortho position. This is O and then C, so again it is OR group at ortho position. So for that also we will add 7 nanometer. Next is meta. At meta position there is only one chlorine, and when chlorine is present at meta, 0 nanometer for this one. Next is para. At para we have OH group, and therefore we will add 25 nanometer for this one. If OH is present at para position, we have to add 25 nanometer, and then you have to calculate lambda maxima. So I think benzoyl system is the easiest system to calculate lambda maxima, and this way we can calculate all these numericals. That's it in this lecture. Thank you so much, and I think this is the end of ultraviolet visible spectra chapter also. Thank you so much.